Alright, good afternoon everybody. Welcome to our third episode of encoder testing. Today we'll be changing devices. We will be showing you guys how we test resolvers. Although these look different to encoders, they are still a feedback device. They consist of two parts. A resolver has a stator and a rotor. Both of these parts have windings inside of them. The way these work is that we will induce a voltage into the primary winding inside the resolver stator, and when we turn the motor, the resolver rotor turns with it, and this induces a voltage into the secondary windings of the resolver, which are our output windings. These are known as our sine and cosine outputs. Okay, resolvers are common devices used in the industry. They're often used in environments that are quite harsh. They work well in high temperatures, they're less susceptible to vibrations, and they are generally just a more rugged feedback device than an encoder. And that is because they do not have moving parts inside of them. Okay, I'm going to take you guys through some tests we perform when checking resolvers. There's not a lot to it. It's a fairly basic device, so we will run through this quickly. Over here we have the electrical angle. We use this when locking up the motor to retrieve an electrical angle prior to stripping it. Once we reassemble the motor after servicing, we restore this angle, and then we know that it is the same. Over here you will see resolver speeds. Resolvers come in many different speeds. The resolver we're using today is just a single speed resolver. It's important this is selected correctly because it will change the electrical angle. The motor I'm using has 6 poles, and the lockup I will be using will be a plus U minus V lockup. In the output menu here we have our vector levels. You can see it is in the green at the moment. This is telling me that the software is happy that my vector levels are falling within the required levels. And then we have our cosine voltage and sine voltage. These are our outputs. I'm going to quickly just show you guys basically what we look for when a resolver is faulty, and I can do that by just simulating a fault, and I will provide the resolver with a very low input voltage of 1 volt, and it's in turn will turn my vector level red. Now the software is telling me that the vector level falls beneath the required level. This would then affect my electrical angle. It would not give me accurate readings. This would happen if the windings in the resolver went open circuit or even short circuit. These are the most common faults with resolvers. Just going to put this back to my original setting. Okay, we're back to normal. Okay, so I'm going to show you quickly how we lock these up. I will move the rotor into a random position and then apply a plus U minus V lockup. You can see we get an angle of 180 over here. If I then go into another random position, lock up again, we go back to 180. I will always get 180, and that is because I have selected the correct amount of motor poles, so I will only get one electrical angle every time I lock the motor up. And that is pretty much it when it comes to testing resolvers. As I said earlier, there's not a lot to them. It's mostly about vector level and retrieving an electrical angle. So that'll be it for today's episode. So thank you for tuning in. If you guys would like to see some more information and more posts, please head on over to our LinkedIn page, or you can head over to our website at www.motiontronic.co.za. Until the next time, cheers guys, bye.